They said quantum mechanics was complete, that everything weird about it, superpositions, entanglement, uncertainty, had already been mapped, measured, and mathematically tamed. But then something happened that shouldn't have. A discovery so strange that even the physicists who made it questioned whether they'd accidentally broken reality itself. It began in a lab, where photons were sent through a device that shouldn't have allowed them to interfere, because by all classical logic, the interference pattern they found meant the particles somehow knew about a decision that hadn't even been made yet. Reality, it seemed, wasn't waiting for us to observe it. It was adjusting itself to our future choices. And that's not a poetic exaggeration. The data showed correlations that should be impossible, unless time itself, or the very fabric of what's real, isn't built the way we think it is. The implications? Either reality is non-local, connected in a way that transcends space, or it's not even real until consciousness or information defines it. For over a century, quantum mechanics has forced us to accept mystery. But now, this new layer suggests something deeper. That the universe isn't just unpredictable, it might be participatory. That we're not passive observers, but part of the mechanism that brings the universe into being. This isn't philosophy, it's experiment. And if what's being found continues to hold true, it means everything we know about quantum reality might be wrong, or incomplete in a way that defies comprehension. It started with what should have been a routine test, a refinement of John Wheeler's delayed choice experiment. Is simple. If you shoot a single photon through a beam splitter, it can take two paths at once, forming an interference pattern. But if you measure which path it takes, the interference disappears. It's as if the photon decides to behave like a wave or a particle, depending on what we ask of it. But the twist came when researchers added a time delay. The decision to measure the photon's path wasn't made until after it had already entered the apparatus. Logically, the photon shouldn't know what was going to happen. Yet every time, the results aligned with the future measurement choice. It was as though the particle's behavior was being influenced retroactively by something that hadn't happened yet. This phenomenon, known as quantum retrocausality, doesn't fit neatly into our understanding of causation. In classical physics, causes precede effects. In quantum mechanics, that rule starts to blur. The act of observation, or even the potential for observation, seems to sculpt reality both forward and backward in time. Then came the even stranger results from quantum eraser experiments. When scientists erased the which path information after the photons had already been detected, the interference pattern reappeared. It was as if reality was rewritten, correcting itself based on information that shouldn't exist anymore. To explain this, physicists proposed several interpretations. Some argued that all possibilities coexist in parallel universes. Each photon both interferes and doesn't interfere in different branches of reality. Others suggested the observer's knowledge, not the physical measurement, determines the outcome. And a smaller, more radical group proposed that time itself might not be linear at all, that events can form loops of causation, where future information influences the past. These experiments aren't fringe anymore. Teams in Vienna, Geneva, and Hefei have reproduced them with increasing precision. Some even used entangled particles separated by kilometers, proving that whatever's happening isn't just a local trick, it's baked into the structure of quantum reality itself. The shocking part is that quantum theory still predicts all these results correctly. Mathematically, it works. But conceptually, it shouldn't. It suggests that reality isn't an objective, continuous thing. It's a negotiation between information, observation, and time. And if that's true, we have to ask a terrifying question. What if the universe isn't something that exists, but something that's decided moment by moment through our interactions with it? We like to think reality is stable, that there's a world out there that keeps existing whether or not we're looking at it. You close your eyes and you assume the room remains, the stars still burn, and the laws of physics hum along indifferently. But the quantum experiments say something different. They whisper that this world might not exist until it's observed, that what we call reality could be more like a continuously rendered simulation, appearing only when there's information to define it. Einstein hated this idea. "Do you really believe the moon isn't there when you're not looking at it?" he once asked. But quantum theory's silent answer might be, not exactly. The moon exists as a probability field, a haze of possible states, until something interacts with it strongly enough to collapse that uncertainty into one tangible version. Think about that. Every solid thing you touch, every object you trust, could be a result of an ongoing conversation between information and observation. The universe isn't built of matter, it's built of potential. Even time, the one thing we assume flows inexorably forward, begins to crumble under this view. If photons can respond to future measurements, then the arrow of time isn't as straight as we thought. Maybe past and future are human simplifications of something far more flexible, a quantum fabric that can stretch, twist, and entangle across what we perceive as moments. To make sense of it, physicists like Carlo Rovelli and others suggest that reality might not even exist by itself, that there's no universal now. Instead, every interaction creates its own version of reality, relational, not absolute. Like two mirrors facing each other, each perspective defines what the other can see. In this light, reality isn't a photograph, it's a conversation. And the participants aren't just atoms and fields. They're interactions, measurements, relationships. The world doesn't pre-exist our experience of it. It emerges through it. If you're thinking this sounds like science fiction, you're not alone. But the math works. The experiments back it up. And when you start to take it seriously, the implications spiral outward into everything we think we know about existence, consciousness, and causality. Because if the universe doesn't exist in a fixed objective way, then what exactly are we living in? At first, most physicists thought these strange results were quirks, artifacts of imperfect detectors or flawed setups. But over time, the evidence didn't fade, it stacked. Each layer peeled away another illusion, showing that reality itself was the variable, not the experiment. Layer 1, the double-slit foundation. Everything begins here. When electrons or photons are fired through two slits, they form an interference pattern, unless we check which slit they go through. The mere act of measurement destroys the wave pattern. This was the first sign that observation shapes outcomes. It shattered classical physics, hinting that reality isn't fixed until it's looked at. Layer 2, Wheeler's delayed choice experiments. John Archibald Wheeler took this madness further. What if the choice to measure comes after the photon has passed the slits? The results? The photon behaves as if it knew our future decision. It's like asking a question in the present that changes an answer given in the past. Layer 3, the quantum eraser breakthroughs. Then came the game changer, the delayed choice quantum eraser. Here, which path information is erased after detection, yet the interference pattern returns, as though the universe rewrote its own history. In 1999, the Kim experiment at the University of Maryland confirmed this with laser precision. Decades later, upgraded versions in Hefei and Vienna proved it wasn't a fluke. It was fundamental. Layer 4, entanglement across distance and time. The most devastating evidence came from entanglement. In 2022, when the Nobel Prize was awarded to Aspect, Clauser, and Zeilinger, it wasn't for proving entanglement exists. It was for proving that no local hidden variable could explain it. The correlations between entangled particles happen instantly, across any distance, defying the speed of light. Worse still, when combined with delayed choice setups, these correlations appear to act across time. Reality is entangled not just spatially, but temporally. Together, these four layers form a ladder to an unsettling conclusion. Reality doesn't unfold linearly. It's not a sequence of fixed events. It's a web of probabilities that only becomes real when information binds it together. The physicists know this isn't a small adjustment. It's a rupture, a discovery that shouldn't exist, because it undermines the bedrock of classical logic, cause and effect, past and future, subject and object. If observation defines existence, if the universe waits for information to crystallize its state, then what's truly doing the observing? Is it us, consciousness, or something deeper, an informational layer that sees without eyes, deciding the world into being? That's the question that keeps even the most rational physicists awake at night. When you first hear that reality might not exist until it's observed, it sounds like a riddle, or maybe a metaphor. But the more you dig, the harder it is to escape the possibility that this is literal, that the universe doesn't simply contain consciousness, it requires it. That's where the philosophical earthquake begins. If measurement defines reality, then what's a measurement, really? Is it a device recording a photon, a brain registering a sight, or the abstract act of information being processed anywhere in the cosmos? In the Copenhagen interpretation, observation collapses the wave function, but it never defines who or what the observer is. For Bohr and Heisenberg, that mystery was a feature, not a flaw. They left it unsolved. But later thinkers like Eugene Wigner dared to push it further. Wigner proposed that consciousness itself, the awareness of the observer, might be the missing piece that causes physical reality to manifest. That suggestion sounded mystical at first. Yet today, with experiments hinting that reality reacts to information, not just physical contact, Wigner's idea doesn't look so far-fetched. Quantum theory seems to obey a deeper rule, one where information and reality are inseparable. As physicist John Wheeler later said, "it from bit," meaning every particle, every event, every atom of existence derives its meaning and its it from an informational bit. Reality is not built from matter, but from meaning. But if that's true, what does it mean for truth itself? If what's real depends on interaction, then truth isn't static. It's relational. Your experience of the universe and mine might literally be different branches of reality, and yet somehow they sync up enough to let us share a world. That synchronization, that intersubjective alignment, might be what we call consensus reality. Critics, of course, reject this as quantum mysticism. They argue the observer doesn't need to be conscious, just part of a system that registers information. Decoherence theory, for example, tries to explain collapse as the result of quantum systems interacting with their environments. It's elegant, but it doesn't eliminate the weirdness. Because even in decoherence, the boundary between the observer and the observed remains blurry. So we're left in a strange position. Science can predict quantum behavior perfectly, yet it can't explain what reality is. That gap, between what works and what makes sense, is where the real revolution hides. And soon, this isn't just going to be a thought experiment. It's about to spill into technology, computation, and maybe even consciousness itself. If reality is built from information, then controlling that information means reshaping the very structure of existence. That's not just philosophical speculation anymore. It's the logic behind the emerging field of quantum information science, where the line between physics and computation disappears. Quantum computers don't just process data faster, they process it differently. They exploit superposition and entanglement, the very features that make quantum reality so counterintuitive. A qubit doesn't represent a single state of 0 or 1, it exists in both simultaneously until measured. Computation, in this realm, isn't about manipulating bits of matter. It's about manipulating possibilities. The strange, impossible discoveries from quantum foundations are already fueling this revolution. If observation defines reality, then maybe we can program reality by designing systems that exploit observation itself as a computational tool. Imagine a world where information and existence are interchangeable, where encryption becomes metaphysical and communication can happen across entangled space-time. Researchers in quantum networks are already experimenting with quantum teleportation, transferring quantum states from one place to another, not through space, but through entanglement. It's not science fiction anymore. It's been demonstrated over distances exceeding 1,200 kilometers using satellite links. Each success brings us closer to a world where distance and separation lose their meaning. And beyond computation, there's the deeper question. If reality emerges from interaction, can we learn to interact differently? Could consciousness, as an informational process, influence physical reality more directly than we realize? Some physicists, like David Deutsch and Chiara Marletto, argue that quantum theory points toward a constructor view of the universe, where knowledge, the ability to cause transformations, is the true fabric of existence. Others are looking toward quantum gravity and the holographic principle, suggesting that the universe itself might be a vast informational surface, encoding everything that happens within it. If these ideas are right, our entire scientific framework could shift. Physics would no longer describe an external world. It would describe the grammar of interaction. The laws of nature would be more like rules of language than immutable truths. And that brings us to a wild possibility, one that no experiment has yet dared to test. If observation creates reality, then could we one day engineer it? Not just simulate it, but literally build worlds from information, universes as real as our own, bound by the same quantum logic. Because if the universe itself is participatory, then maybe, just maybe, we're not just witnesses to creation, we're part of it. Let's step back for a moment. Forget the equations, the lab setups, and the Nobel Prizes. Think about you, the way you see the world, the way you assume it's just there, solid, indifferent, permanent. But if quantum reality is participatory, if existence unfolds through observation, then your awareness isn't just noticing the universe, it's part of the mechanism that creates it. That thought can feel terrifying or liberating, depending on how you hold it. Terrifying because it means there's no solid ground. Liberating because it means you're not a spectator in an indifferent cosmos, you're a co-author. Every perception, every observation, every act of attention, it all contributes to the quantum fabric of what is. You're entangled with everything you've ever seen, touched, or thought about. Not metaphorically, but literally, through the informational connections that define reality. The act of awareness links you to the universe in a way no boundary can separate. This changes what being human means. It's not just biological existence anymore, it's participatory existence. You're not a passenger, you're a participant in the unfolding of time and matter. The distinction between observer and observed mind and world starts to blur until it disappears. Even everyday choices start to feel different when viewed through this lens. Every decision you make, what to say, where to look, what to believe, might be more than a simple act of will. It might be a kind of quantum selection, narrowing the possibilities that reality will render next. Maybe that's what free will has always been, the capacity to choose which version of the universe you'll live in. This doesn't mean we can wish ourselves into other worlds or bend physics by sheer thought, but it does mean that attention matters in a literal, physical sense. The universe seems to care when we observe it, and not just care, but respond. We used to think consciousness was a side effect of the brain, a flicker of light inside a lump of matter. But what if the brain is the other way around? What if consciousness is the field, and the brain is just one of its instruments? If reality only crystallizes through awareness, then awareness isn't an accident of the universe. It's its mirror, maybe even its source. And that raises one last unavoidable question, the one that bridges science and meaning, physics and philosophy. If the universe depends on consciousness to exist, then what happens when consciousness learns to understand itself? Maybe the strangest realization of all is that quantum physics, the most precise, successful theory ever built, keeps pointing us back to something profoundly human, not to our instruments, but to our experience. To the simple, impossible fact that we're here, and somehow the universe seems to need that. Picture yourself walking late at night. City quiet, the air electric. Streetlights shimmer on wet pavement. Every step you take echoes off the buildings, and for a brief moment, you feel the universe listening. Not metaphorically, but literally, like each observation you make pins a tiny fragment of existence into place. The light, the sound, the texture of the world, all of it participating in a grand act of co-creation. That's the hidden beauty inside the chaos of quantum reality. The universe isn't a machine that runs without us. It's a relationship, an unending dialogue between mind and matter, possibility and perception. The mystery isn't that we can't find ultimate reality, it's that we are part of it. Every discovery that shouldn't exist, every impossible experiment, every paradox, might not be breaking the rules. It might be showing us that the rules were never what we thought. And maybe that's the ultimate discovery, that to understand the universe is to realize it's looking back. Do you believe this quantum idea changes everything? Or is it just science fiction? Tell me below. Your view might change someone's mind.